Today, machine learning powers everything, from Netflix recommendations to fraud detection to chatbots. But here is the reality. Most machine learning models never reach production. And even if they do, they fail. Why? Because building a model is easy. Running it reliably in the real world is hard. And that is exactly where MLOps comes into picture. In this video, we'll understand MLOps end-to-end, deeply and practically. Hi, I'm Sudhakar Kakkireni, 25 years in IT industry. So what is MLOps? MLOps stands for Machine Learning Operations. It's a combination of machine learning, DevOps, data engineering. Machine learning, it builds models that learn patterns from data to make predictions or decisions. DevOps, it combines development and operations to automate, deploy and manage software systems efficiently. Data engineering designs and manages data pipelines to collect, process and store data for analysis in ML. The goal is simple: build, deploy, monitor and maintain ML models in production systems. Think of it like this: machine learning creates the brain. MLOps builds the entire body around it. Without MLOps, your model is just a notebook experiment. Why MLOps is important? Let us understand the real problem. A data scientist builds a model in a Jupyter network. It works perfectly. But when we try to deploy it, it crashes. Data is different. Performance drops. The gap is called the ML production gap. Without MLOps, no version control means there is no proper tracking of changes in data, code or models, making it difficult to manage updates. No reproducibility. The same results cannot be recreated consistently due to lack of proper tracking and environment setup. Manual deployment. Models are deployed manually, which is time consuming, error prone and not scalable. No monitoring. There is no system to track model performance in production. That leads to unnoticed failures. With MLOps, automated pipelines means end-to-end workflows are automated, reducing manual effort and increasing consistency. CI/CD/CD, continuous integration, deployment and training ensures faster, reliable and up-to-date ML systems. Scalable systems, models can handle growing data and user demand efficiently without performance issues. Continuous improvement, models are regularly updated and improved using new data and feedback. MLOps turns experiments into reliable production systems. End-to-end ML lifecycle. As part of that, step 1, data collection. Every ML system starts with the data. Sources are databases, APIs, logs, IoT devices. Example, in e-commerce, user interactions such as clicks and purchases generate valuable data for ML models. As part of end-to-end ML lifecycle, step 2 is data preparation. Now comes one of the most important steps in machine learning. In fact, 80% of the effort in ML projects goes into preparing data, not building models. Several key activities help in data preparation. Number 1, data cleaning. Raw data is never perfect, it is messy and inconsistent. So the first step is cleaning the data. What do we clean? Missing values? Some fields may be empty. Example, age is null. What is the solution? You remove the rows or fill with the mean or median. Use advanced imputations. Next one, duplicate data. Same record repeated multiple times. It can bias the model. It can make the model learn incorrect or misleading patterns. Solution is remove duplicates. The other one, incorrect or noisy data. Example, age is 200. Invalid entries. Solution is filter or correct the value. Outliers. Extreme values that distort model. Example, salary is 10 crores. Solution is remove or cap the values. Without cleaning, even the best model will fail. The second key activity in data preparation is data transformation. After cleaning, we transform the data into a format suitable for machine learning. Types of transformations. Normalization or scaling adjusts data values to a common range so that models can learn more effectively. Example, 0 to 1. Why? ML algorithms performs better here. The other point here, encoding categorical data. Convert text into numbers. Example, cities, Hyderabad, Delhi, so converts to 1, 2. So encoding types, label encoding and one-hot encoding, they convert categorical data into numerical format. So a ML model can process it. Next one is as part of data transformation, text processing. Remove stop words. Removes common words like the, is, and that do not add meaningful value. Tokenization splits text into smaller units like words or sentences for processing. Stemming reduces words to their root form, such as running to run. This step ensures the data is machine readable. Next key activity is feature engineering. This is where real intelligence comes in. Feature engineering means creating better input variables for the model. Example, from date we extract day, month, year, weekend, weekday. From transaction data, total amount spent by a user over a period of time, indicating purchasing behavior. Frequency of purchases, how often a user makes purchases, helping identify engagement patterns. From text, sentiment score, a measure of the emotional tone, positive, negative, or neutral in the text. Word count, the total number of words in a text used as a basic feature for analysis. So the point is, good features can improve accuracy more than changing the algorithms. Next key activity is feature selection. Not all the features are useful. Some may actually harm the model. For example, irrelevant columns. Features that do not contribute useful information for model predictions. Highly correlated features means features that are strongly related to each other, causing redundancy in the model. Techniques. Correlation analysis. It identifies relationships between features to detect redundancy or dependency. Feature importance measures how much each feature contributes to the model's predictions. So removing unnecessary features improves performance and reduces complexity. Next key component as part of data preparation is data splitting. Finally, we split the data into training data, which is 70 to 80%, and testing data, that is 20 to 30%. Train model. So we use training data to learn patterns and build the model. Evaluate performance. Test the model on unseen data to measure its accuracy and effectiveness. This ensures the model works well on unseen data. If your data is bad, your model will be bad. In MLOps, data preparation is not a one-time task. It's automated using pipelines, ensuring consistency and reproducibility. Okay, after data preparation, model training. Now comes model training, where we teach machines to learn patterns. What happens here? We select an algorithm. Example, linear regression, a simple algorithm used to predict continuous values based on relationship between variables. Decision trees, a model that makes decisions by splitting data into branches based on conditions. Neural networks, a powerful model inspired by the human brain that learns complex patterns from data. Okay, next is train model. As part of that, feed data provides input data to the model for learning. Learn patterns, the model identifies relationships and patterns within the data. Then another one is hyperparameter tuning. Controls how quickly the model updates during training. Depth of tree defines how complex a decision tree can grow. Number of layers determines the depth and complexity of a neural network. This step is not just training, it's about finding the best performing model. So next step is model evaluation. Once trained, we must evaluate the model. Model performance is evaluated using classification and regression metrics. Classification, under these metrics, accuracy, the percentage of correct predictions out of all predictions made. Precision, the proportion of correctly predicted positive cases out of all predicted positives. Recall, the proportion of actual positive cases correctly identified by the model. F1 score, a balanced measure that combines precision and recall into a single score. Regression metrics, under this, root mean squared error, RSMA. It measures the average magnitude of errors, giving higher weight to large errors. Mean absolute error, MAE. This measures the average absolute difference between predicted and the actual values. Evaluation ensures the model is trustworthy before deployment. Next is step 5, model deployment as part of end-to-end ML lifecycle. This is where most ML projects fail. Deployment means making the model available for real users. Deployment methods are REST API, it serves model predictions in real time through API requests. Batch processing, it processes large volumes of data at scheduled intervals to generate predictions. Streaming systems process data continuously in real time for instant predictions. Deployment tools are Docker, it packages applications and models into containers for consistent deployment. Kubernetes, it manages and scales containerized applications efficiently in production. Now your model becomes a real product. Step 6 is monitoring. Deployment is not the end, it's the beginning. What to monitor? Model drift. It monitors when the model's predictions become less accurate over time due to changing patterns. Data drift. When the incoming data distribution changes compared to the training data. Accuracy drops. It monitors about when the model's performance decreases on new or real world data. So models degrade over time. Monitoring keeps them healthy. Step 7. Retraining. When performance drops, we retrain the model using new data. Retraining types are scheduled retraining. Here, models are retrained at fixed time intervals using updated data. Trigger-based retraining. Here, models are retrained automatically when performance drops or specific conditions are met. This creates a self-improving ML system. MLOps architecture. A typical MLOps architecture includes multiple pipelines. The components are data pipeline. It collects, processes, and prepares data for model training and inference. And the training pipeline, it automates model training, evaluation, and validation process. Model registry, it stores and manages versioned approved models for deployment. Deployment pipeline, it automates the process of deploying models into production environments. Monitoring system, it continuously tracks model performance and system health in production. Think of it as a factory where models are continuously built and improved. CI/CD CT for machine learning. In DevOps, we have CI/CD. In MLOps, we extend it to further. CI is continuous integration, automatically validates code and data changes to ensure consistency and reliability. CD is continuous deployment, automatically deploys models to production for faster and reliable releases. CT is continuous training, automatically retrains models using new data to keep them up to date. This makes ML system fully automated and scalable. Key components are data versioning, track dataset changes. Tools are data version control, an open source tool used to version and manage datasets, models, and ML pipelines alongside code. Model versioning tracks model history. Tools are MLflow, an open source platform for tracking experiments, managing models, and streaming the ML lifecycle. Experiment tracking records and compares different model runs to identify the best performing model. Model registry stores and manages approved models for versioning, tracking, and deployment. Deployment deploys models as APIs or microservices so they can serve predictions in real time. Monitoring tracks model performance using dashboards and alerts to quickly detect issues. So these components ensure control, traceability, and reliability. Tools in MLOps, let's see popular tools. ML tools, machine learning tools, MLflow, an open source platform to track experiments, manage model, and streamline ML workflows. Kubeflow, a Kubernetes-based platform to build, deploy, and manage scalable ML pipelines. TensorFlow Extended, TFX, a production-ready framework for building and deploying end-to-end machine learning pipelines. DevOps tools, Docker packages applications and their dependencies into containers for consistent deployment across environments. Kubernetes, it orchestrates and manages containerized applications at scale, ensuring reliability and scalability. Pipeline tools, Airflow, an open source tool to schedule, automate, and manage complex data and ML workflows. Each tool plays an important role in building end-to-end ML systems. A real-world example. Let's take a real-world example. Fraud detection system. A system we can use machine learning to identify and prevent fraudulent transactions. Flow is data from transaction, collects transaction data such as payments, amounts, and user activities. Then data preparation, cleans and transforms raw transaction data for model training. Then model predicts fraud. The trained model analyzes transactions to detect potential fraud. API serves prediction. The model's predictions are delivered in real time through API. Monitor performance, tracks model accuracy and behavior to ensure reliable fraud detection. Retrain models, updates the model with new data to improve accuracy over time. This is how MLOps works in real companies. Challenges in MLOps. MLOps is powerful but challenging. Challenges are like data quality issues. Poor or inconsistent data can negatively impact model accuracy and reliability. Model drift. Model performance degrades over time as the real world pattern changes. Infrastructure complexity. Managing multiple tools, pipelines, and environments makes system difficult to maintain. Scaling. Handling increasing data and user demand efficiently can be challenging. That's why skilled MLOps engineers are highly valued. Now, career path. MLOps is one of the fastest growing careers. Roles like MLOps engineer, who builds and manages pipelines to deploy, monitor, and maintain ML models in production. ML engineer, who designs, develops, and optimizes machine learning models and systems. AI engineer builds intelligent systems that apply AI techniques, solve real world problems. Skills you need to learn Python, a widely used programming language for building machine learning models and automations. Cloud, any cloud, Azure, AWS, GCP, provides a scalable infrastructure to store data, train models, and deploy ML systems. Docker enables packaging applications and models into containers for consistent deployment. Right? Kubernetes automates deployment, scaling, and management of containers applications. So if you combine machine learning and DevOps, you become extremely valuable. Let us summarize. Machine learning builds models, MLOps builds production systems. If you want to build a real-world AI, MLOps is not optional. It is essential. If you find this video useful, like, comment, subscribe. You can tell me in the comments if you want more detailed technical insights. Without MLOps, machine learning is just an experiment. With MLOps, it becomes a real, powerful AI product. Have a good day. Thank you.